Welcome to a new short tutorial about how to build a real-time thermometer with F#, the Safe Stack and a Raspberry Pi. In this tutorial we will cover 4 things. Build a simple data stream for the temperature data in Saturn. First we use some random data, and in the last step we switch to the real data from my GrovePi. Use Saturn channels to build a WebSocket connection which sends the data to the web clients. Use Elmish to consume the WebSocket messages and display the temperature and humidity. And finally, build an Elmish wrapper around a React component to display the data in a fancy way. Let's start. The first thing I'm gonna do is create a project from the Safe Stack template. Here I'm using the new minimal version 2 of the Safe template. While I made this video, the version 2 of Safe Stack hasn't released yet. I installed it manually from the Git repo. Type .NET new safe, give it a proper name with the end parameter, here Raspberry safe temperature, and use the parameter minimal to get the minimal version of this template. So, it's created. Let's open it in Visual Studio. The first thing I'm gonna do is update the containing NuGet packages. Let's start with some code. First we make it a little bigger here. First, what we doesn't need is any kind of HTTP endpoint, so we didn't need a router. So no router is our friend. Now we need a new F# source file where we put our temperature service into it. Now we create a function which returns our temperature service. The first thing what we need is an F# event. This event will be raised every time a new temperature is available. But before we can do this, we need actually a record where we put our data into it. So open the shared project, remove the old stuff, and put in our data model. We need the temperature as float. Also we get the relative humidity from our Raspberry Pi. Also a timestamp is a nice thing. We've got our data structure. Let's go back to our temperature service. Let's open our shared namespace and use it for our event. Let's write actually the task function which puts the data into our data stream. Let's wrap it into a task computation expression. For this tutorial I will create an endless while loop. I think the task computation expression doesn't work very well with recursion, I think, currently. In order to get some intelligence, we have to open some namespaces. At first for the task computation expression and then for our task itself. The first thing what our service does is wait a second. So in the future, we want every second data from our thermometer. Let's trigger our event with some temperature data. Open the module of our temperature data so that F# recognize our data structure. Instead of static data, we should use some random data for our temperature and humidity. So the temperature and the humidity are now random values every second. So let's return the temperature changed event as observable and the task runner itself. So this is our temperature service for now. Now we want to add some channels. For that, we open first the namespace for our task computation expression. Then let's create our simple channel. The only thing that we want is when somebody joins our channel, we want to print a message. We use join, we get some context and a client information. And we print out that somebody has connected. Finally, we return some OK. And I forgot to wrap it in a task computation expression. Now add the channel to the application builder. The first parameter is the endpoint of our channel, and the second parameter is actually the channel that we wrote on top. Now we need a send message function which sends our messages over the WebSocket channel. The first parameter is our iSocket hub. The second and the third is a topic and our payload for our message. This function runs asynchronously, so we wrap it in a task. At first we need a message, so we serialize our payload into JSON for that. Finally, we call our send message to clients, which actually sends the message to all connected clients. The first parameter is our channel endpoint. Let me fix that. The second one is our topic, and the third one is our message. So we got our send message function. What we want in our little application is that the temperature data stream should start with our server. For that, I will extend the application builder with a simple function, which can be used to run stuff while the server is starting up. While I'm in the post process of this video, I know that there is a built-in function in the application builder, so this step is actually not necessary. But it's always kind of nice to know how things are done. In this case, how to extend the application builder. For the extension, I created a module application extension and opened some namespaces that we need. We extend the application builder with a new member, start custom process. The first parameter is always the application state, and the second parameter is the task function, which should run. Let Visual Studio add some needed namespaces, and that the custom operation attribute. Now create our little middleware function and use the iApplication builder from ASP.NET Core. And what will we do here is actually to run our task function inside a separate task to avoid maybe a deadlock situation. And finally return the application builder. And as return value of our extension function for the Saturn application builder, I return a new application state where we add our app builder config function to the rest. Now we have our application builder extension in place. Let's use it. Let's open our extension module and start write our custom function. At first we need our WebSocket hub in order to send any messages to the WebSocket at all. For that we ask the integrated ASP.NET Core dependency injection to give us our socket hub. And again we need to open a namespace for the iSocket hub interface. Now we call our createTemperatureService function. The return functions are actually our data stream for the temperature and our task runner. Now we add a subscription on our temperature stream. Every time we get a new data from our stream, the sendMessage function is called. So sendMessage, our socket hub, the topic, name temperature, and our temperature data. And we are ignoring the return value. Oh, and I realized that I forgot the task computation. And ignoring that. And finally we start our temperature service itself. Now let's test our service. For that I add some breakpoints here and start our server. It's building and started, and we hit our breakpoint. And we got our WebSocket hub. And our temperature stream emits his first event. And here's our data. Okay, our temperature service is running and emits events as expected. Let's stop this here and continue with our client. The first thing I'm gonna do is remove the unnecessary NuGet package like thos-fetch, which we didn't need it, and add new ones. The first one I needed is thos-json. The second one is Phillies. And the third one is the Fable WebSocket extension. Fable.browser.websocket. Let's have a look into the app.fs file. Here we don't need to change anything. But here in the index file we need to clean up. We need to open thos-json, browser WebSocket and Phillies. And now delete the rest. The first thing to do is write our model. It contains our temperature data as an option, because we have a state where no temperature data is available. Then we need our messages. There's only one message to set the temperature. Now let's write our init function. It returns our model with our temperature data as none and currently no command. Then write our update function. The first parameter is the message which come in and the second is the model. Let's make a pattern match on the message. We have only the set temperature data message. As a return value, we get a new model with our temperature data and no command. And finally, let's add our view function. The first parameter is the model, the second parameter is the dispatch. The only thing we are doing in there is to display a div, and in this div we display 3 paragraphs, one with the temperature, one with the humidity, and one with the timestamp. But first of all, we have to check if our temperature data is currently set. If we didn't have any data, display the text "no data yet." And if we have some data, let's display them, as I said, in 3 paragraphs. The temperature is a float. The humidity also. And the timestamp we will format a little bit nice as string. Okay, that's it for now. Let's have a look if our client will run. For that, I will change the directory to our client and run npm install. So let npm now install our things. And we are done. Now run the Webpack dev server. And we see our "no data yet" message. Now we write our Elmish command, which connects to the WebSocket and receives the data for us. Create a module for our commands and open some namespaces we need. The first thing we need for our command is actually the record type for our channel message. It contains the topic, a string, and our payload, a string. What we then need is our command itself, connect WebSocket command. For this command we use the subscription command extension, which gave us the ability to use a dispatch in our command itself to send messages, like we can in the view function. Inside our function we write a little recursive connect function, which actually connects our WebSocket. At first we need the endpoint of our WebSocket, so we look into our server and copy our endpoint. Now that I'm thinking about this, we have to look into the Webpack config file and look for the proxy, and we see the proxy for the WebSocket is actually /socket/any address. So we need to change our endpoints from channel to socket. It's also possible to change the Webpack configuration to channel instead of socket. Now let's copy the endpoint for the client. Now create the WebSocket and add some event handlers. When the WebSocket connection is open, we actually print out that the connection is open. In the case the connection closed, we want to implement a reconnection functionality. At first print out that the connection is closed. Now I want to wait 2 seconds and reconnect, but I realized I forgot to install an additional package. Fable Promise is needed for that. After the installation, Nougat complains that Fable React needs also an update. So we do that. So let us update all. And we are done. Back in our connect function, we use promise to wait 2 seconds until we reconnect. Now we have to implement the event when we receive a message. For that, we write our own little function. What we now need is a little helper function which deserializes our channel message, which is in JSON, into our record type. And because we need the deserialization again for another type, we built a generic function. So decode the data into the channel message. And now we will check if the topic is correct. Let's look back into the server and look for the topic. Here in the send function we have a topic parameter, and there temperature is our topic which we use. So temperature is this. If we have our topic right, then we deserialize our payload into the temperature data and then put it into our set temperature data message and dispatch it. In every other case, we ignore the message. Now add our function to the onMessage handler. And finally call connect. Now we are finished with the connection part of this command. Let's put the whole anonymous function into a Elmish subscription. This is our anonymous function, and we pipe it into a subscription command. Now we are done with our WebSocket connection command. Let's run it in our init function. When our application starts, we trigger the connect WebSocket command and get in connection to our WebSocket. The compilers say something is wrong with our promise sleep. We forgot actually a do bang. Also, we didn't have a proper WebSocket URL, so I have to fix this. I will use the host address to build a proper WebSocket URL. Also, I will add the port to the address. Here I did a little mistake because the host address contains already the port in that case. So I remove the port. Let's have a quick look if it's all running. No error messages anymore. Let's start our server and see if we get some data over our WebSocket connection. The server is running and we see some data here. Here we see the random sequence of our humidity and temperature. Awesome, our WebSocket connection works. Let's fix the position of our floats. Now the temperature is more readable. Let me do a quick refresh. Here's our data. Awesome, our architecture works. Now we want to display our temperature and humidity in a more fancy way. So I'm going to the internet and I found a gauge plugin for React, which we're gonna use in our case. Now what we're gonna do is to build an Elmish wrapper for this React component. So let me switch to our terminal, make this a little bigger here. and stop our Webpack dev server. Now the first step is to install our Gauge React component. For the second step, we need to modify the Webpack configuration file. In this case, I use a minimal version, so we have to add a few things. This part is necessary because the gauge element uses CSS and the minimal template of save doesn't contain any CSS or SASS handling. If you are using, for example, the old save stack template, then the Webpack configuration file contains the necessary stuff to handle CSS files. So what I'm gonna do is add the necessary parts for handling CSS and Sass files. The first thing is the mini CSS Extract Plugin, which is needed when we want to build the final production version of our client. Let me install it with npm install. Done. Now we have to go to the module section and add the CSS and Sass file handling. Now we have to install the plugins which are mentioned in this code snippet. The first package I want to install is a style loader. Now the CSS loader. The resolve URL loader. The Sass loader. And finally Sass. Now we have all needed packages installed. Now as our last step in the Webpack config file, we have to add the CSS Extract plugin into the plugin settings in case of a production build. We are done here. Let's switch back to our client and implement the gauge. So we add a new module for our gauge element. Open a necessary namespace, fable.core.js interop. Now let's import our gauge React element. Now I'm pasting a little helper function that merges two objects with all its properties to one JavaScript object. It's the wrapper for the object assign function in JavaScript. For the emit attribute, we need to open the namespace fable.core. Now we need an interface for our gauge properties. Basically, every React element has a property. So let's have a look what we need. We need an ID, number of levels, %. As we see here, the property ID is the required property. Number of levels is the number of parts in which the gauge is parted. % should be clear. And finally, we need format text value because we want to display the temperature in Celsius and not in percentage. Let's make us notes which properties we are needing. ID, number of levels, %, and format text value. Now we create a subtype where we put in our properties in Felis style. The first member is number of levels and it takes an integer as a value. What we're gonna do is create a key value tuple and unbox it into our gauge property interface. And I was missing our ID property. Let's duplicate our line and change the values. ID needs a string. So let's do the same for the rest of our property. % and format text value. % takes a float. We will name format text value only to value. It takes a function with a % as parameter and returns a string. So we will only use the input value and display it directly as string and ignore the % here. Now we create the main type of our gauge. Here we have only one static member which displays our gauge and takes a list of our gauge properties. Now we create an object with some defaults. Basically, they are not necessary here, but for the sake of this tutorial, I will put this into it. The body property isn't needed anywhere, but it's possible to add here some defaults. Now we will call interop.createReactElement. The first parameter is our React component itself, and the second parameter is an object which contains our React properties as object properties in it. We use here the object assign function to merge the default object and the component's property object into one. To convert the value key tuple into an object, we use here the createObject function and unbox our properties into it. The double bang is the Fable version of an unbox. Now we are done. We can actually implement our gauge element into our view. Let's open our gauge control module. We call gauge.gauge and put our needed properties into the first parameter. Let's start with ID and give the element a proper unique ID. Let's set the number of levels to 25. At the temperature of a part of 100, the highest temperature should be 50 degrees in this case. Now we want to display the actually degrees of our temperature. So we are done for our temperature. Let's have a look. Let's start the Webpack dev server. As the client is building, I want to mention that we only consider a positive temperature in that case. You should change the percentage formula to display all negative values, as for example lesser than 50%. But for the sake of this tutorial, we leave it. Also in the house where I'm using the thing, the temperature shouldn't run under 0 degrees. We are done. Let's have a look. Let us run the server so we get any data. Also, we are seeing our temperature in a fancy way, but the background doesn't fit. So let us change the background and make it a little bit darker. To do that, we go to the index.html file and add some style sheets for the HTML and body. Let's set the height to 100% and the background to a nice dark color. Let's restart our server and have a look. Refresh the page. Now it looks perfect, except we miss the degrees Celsius. Let's add it to it. Let's look again. We have a UTF-8 format error because of a special character in degrees Celsius, but we are leaving it for now and solve the problem later. Let's add now the gauge for the humidity. For that I'm lazy. I copy the temperature and change the parts which I need to change. We use the number of levels to 5 and modify the formula for the humidity. Humidity will be displayed in percentage, so we don't need the value property anymore. and use the default setting of our gauge, which uses % as unit. Let's have a look. Awesome, it looks nice. Now let's solve our problem with a special character in degrees Celsius. To do that, we only have to save our code file in UTF-8. As default setting, Visual Studio doesn't save files in UTF-8. We are going to the Save As dialog and save the file as UTF-8. So let's have a look. And now our degrees are displayed correctly. Awesome! The final step is now to rewrite our temperature service to read the real temperature and humidity from our Raspberry Pi. In order to do that, we must install two NuGet packages, iot.device.bindings and system.device.gpio. These libraries did contain a lot of nice bindings for different IoT devices, so it's also built for .NET Core and we can use it in our Saturn server. Also, in my case, I will use the latest pre-releases of these packages because I run into an error with my thermometer and my GrovePi. For my device, the error is fixed in the pre-release packages. So here I am installing system device GPIO, and now I search for ito.device.bindings. We are done. Let's go back and use these libraries. Please be aware the lines of code that I'm writing are only for my GrovePi. If you have another Raspberry Pi, please look it up. How do you read actually the temperature data from it? First, let's open some namespaces. So now I have to initiate my GrovePi. And now let's initiate our DHT-Sensor. We put in our GrovePi, and the second parameter is actually the port where I put in the DHT-Sensor. In my case, it's a digital port 7. As a third parameter, I put in the DHT type. In my case, it's a 22 because it has a better resolution than the others. Now, after we wait 1 second, we actually read the data from our DHT-Sensor. Now we put the data from the DHT-Sensor into our data structure. Here in my case, it's the last temperature property. And in case of the humidity, it's the last relative humidity. So that's all the changes we are needing for our temperature service. Now we will install the stuff on our Raspberry Pi and run it. In order to do that, we will compile our client with Webpack to a production version. Then we go to our server and build it too. I will not create a special release here. I stay with the debug version. Now let's copy the files to our Raspberry Pi. What's not part of this tutorial is the installation of .NET Core 3.1 on the Raspberry Pi. There are enough sources in the internet and nice tutorials which shows you how to do that. We copied our server. Now we have to look into our server to get the name of the path where we have to put our client data into. In our case, it's public. Let's create the folder on the Raspberry Pi inside the server installation folder. Now let's move into the folder where our client is deployed and copy the files to the server. Now we are done. Let's start actually our server on the Raspberry Pi. For that, change it to the folder where We copied our server and run .NET server DLL. Now the server is running. Let's have a look. Awesome, it works. Nice. You see, we now have our little real-time thermometer on our Raspberry Pi written in F# with a safe stack. Also, you see, we have a very hot weekend here today, and in my office it's 31 degrees Celsius. So, thank you for watching my video. I hope you enjoy this. Please leave a comment, post on Twitter, send me a message, anyone else, give me some critiques. So thank you and bye. By the way, what you are seeing here is my GrovePi. So now, bye bye.